When we evaluate the indefinite integral, we just did this example using trig substitution, but now we'll find the same antiderivative using basic u-substitution. Normally, when performing basic u-substitution, we let u equal the higher degree part of the integrand, hoping that differential u matches the remaining part. But in this example, that's not going to work. We'll let u equal the radicand of 25 minus x squared. So if we let u equal 25 minus x squared, notice that differential u would be equal to negative 2x dx. So if we divide both sides by negative 2, we can say that negative 1/2 differential u equals x dx. Now there's a slight problem here. Notice how we have x cubed dx, not x dx. So this x here will take care of one factor of x, but we'll still have a factor of x squared. So you might be thinking, what should we do with that? Well, if we let u equal 25 minus x squared, we can solve this equation for x squared and then perform a substitution for the x squared in terms of u. So if we add x squared to both sides and then subtract u on both sides, we'd have x squared equals 25 minus u. And now we'll write the integrand in terms of u using this equation, and this equation. To better see how this works, let's rewrite this as the integral of x times x squared. There's our x cubed. And let's write the square root of 25 minus x squared as the quantity 25 minus x squared to the 1/2 dx. And now we'll perform our substitutions. So x dx is equal to negative 1/2 du. We'll factor out the negative 1/2. Here's differential u. X squared is equal to 25 minus u. And the quantity 25 minus x squared is equal to u. So we have times u to the 1/2. Now let's go ahead and distribute. So we have negative 1/2 times the integral of, this would be 25 u to the 1/2. And this is u to the first, so we have minus u to the 3/2. And now we'll find the antiderivative with respect to u, then we write it in terms of x. So we'll have negative 1/2 times 25 times the antiderivative of u to the 1/2 would be u to the 1/2 plus 1, that's u to the 3/2, divided by 3/2. But instead of dividing by 3/2, let's multiply by 2/3. So we'd have u to the 3/2 and then times 2/3 minus the antiderivative of u to the 3/2 would be u to the 5/2 divided by 5/2, or 2/5 times u to the 5/2. Now let's go ahead and distribute. Notice in this first product, the 2's will simplify out, leaving us with negative 25/3, and then u to the 3/2, since u is equal to 25 minus x squared, would be the quantity 25 minus x squared to the 3/2. Now for the next product, notice how we have a negative times a negative, that's going to be positive or plus. Once again, notice how the 2's simplify out, so we have 1/5 times u to the 5/2, but again u is 25 minus x squared, so this quantity is raised to the 5/2 power, and then we have plus c. This would be our antiderivative. So notice how by performing this u-substitution, the problem is actually much shorter and cleaner than using trig substitution. I hope you found this helpful.